Good evening, and thanks for coming out tonight. This is the start off of our fall semester, our Universe Revealed lecture series. My name is Deb Marr, and I'm a professor of biology at Indiana University South Bend, and I'll be serving as the moderator for tonight's talk. Just so you know, so the exits and the restrooms are, you can go either way, just straight out the back of the auditorium. In case this is your first time here, the Our Universe Revealed lecture series includes talks in the sciences and also the cross-section between the sciences and the arts, so STEAM for everyone. And this is a partnership between the St. Joseph County Public Library, Indiana University South Bend, as well as the University of Notre Dame. This is actually the 10th year of this lecture series. It started off the first 6 years only at Notre Dame and only physics and astronomy. And then 4 years ago, we branched out to all fields of science, and we moved it to the library downtown so that it's more easily accessible for people. And if you missed previous talks, if you just type in Google Our Universe Revealed Notre Dame, you'll pull up the website, and you can look at previous talks on the website there. So we're kicking off our 10th year this year with professors from University of Notre Dame and IU South Bend who are using environmental sensors to study both locally and globally our air and water quality, as well as weather and climate change. I'm going to talk just a little bit about each of the speakers so you know who they are, and then Henry Scott will talk first about projects he's been working on, and then Wade McGillis will talk about projects he's been working on. So a little bit about Henry Scott. He received his Bachelor of Science in Applied Physics from Indiana University of Pennsylvania, and then a PhD in Earth Sciences from the University of California, Santa Cruz. He then did a postdoctoral fellowship at the NASA Astrobiology Institute in the Carnegie Science Lab in Washington, D.C. He's currently a professor in physics and astronomy and serves as the Associate Dean for the School of Natural Sciences at IU South Bend. Henry's actually a geophysicist. His main area of research is studying the deep interior of planets using applications of experimental high-pressure mineral physics. He also teaches courses in earth and planetary sciences and the physics of sound. And through teaching meteorology, that got him into weather. And so he became really interested in weather, and he's been developing a network of local weather stations as a way to give students firsthand experience studying meteorological phenomena based on local weather events. And so he'll be getting into that tonight. Henry has partnered with area high school teachers and also the Ethos Innovation Center in Elkhart to develop projects that engage kids in science. And then Wade McGillis, he received his Bachelor of Science in Mechanical Engineering at Northeastern University in Boston. He then skipped over to the other side of the country to do his PhD in Mechanical Engineering at the University of California, Berkeley. He then skipped back over to the east side to do his postdoctoral work at Woods Hole Oceanographic Institute, which is in Massachusetts. And then he served as the director of the Center of Rivers and Estuaries at Columbia University in New York City. And there he was mainly studying the Hudson River and water quality issues. He came to the University of Notre Dame in 2022 and has been working on air quality and greenhouse gas emission projects that directly relate to the air that we are breathing in this region. And his work has been featured in the New York Times. He has numerous publications. So without further ado, I'm going to turn it over to Henry first, and then Wade, and then we'll have time for questions. Thanks.
Well, thank you all for being here. So we've only recently started working together. We've both done most of our work separately in really very different areas, but that's one of the nice things about partnerships between IUSB and Notre Dame is that you can develop new relationships. In fact, I see Barbara Dale is here. We know each other through Barbara Dale from the city of South Bend, so thank you for the introduction.
I called Barbara today, but she didn't answer my phone.
She has caller ID. Yeah, so I would like to talk to you about this project, and Deb, I really appreciate the introduction because that was correct. I'm not a meteorologist, but I will be talking about weather data or other pieces of information that we can easily collect from the local environment. And the theme of what I've been working on the last few years is an interest in trying to make such information readily available to people in the public, colleagues, students especially for teaching, because as I was teaching meteorology classes, I really didn't like relying on the textbook for figures. Instead, when there'd be an interesting weather phenomenon, I wanted to be able to show data from something that the students had just experienced. And I was surprised that was not extremely hard to do, but not as easy as I would have liked. So that's been the primary motivation for what I'll be talking about. So the fruit of this has been the Titan Weather Network, which is still fairly small. It's only about 5 or 6 weather stations in our local region. And the goal for these is to make it so people can pull information from these weather stations as easily as possible to then do whatever they want with those data. There's a lot of information out there and visualizations through the internet. There's a tremendous amount. But again, the goal here is to make it so people can obtain the data themselves for doing their own analysis. So easy access is really key. And the project itself has been to acquire weather stations that are cheap enough that we can essentially give these to local schools. So the model we've been using, we can pass this around if you'd like. This is one called the Tempest. There are a few companies that make similar products, but this is my favorite one. There's a consumer version that's only about $300, $350. For the project we're doing, they're a little more expensive, approaching $600, $700. However, they make them with a discount. So if they're going to schools that are from kindergarten through 12th grade, the discount brings them back to that same $300. So it's a really low level barrier to get started with these. And these stations collect all the standard weather elements from temperature, pressure, humidity, wind data. And the reason I like them so much, though, is that there are no moving parts to these whatsoever. The precipitation information comes from the top surface, which has a haptic sensor. So it's just the vibration from precipitation landing on it. Doesn't work so well for snow, but for rain, it's great. Wind, there is a series of ultrasonic sensors inside. So just the sound of wind blowing through it is how it picks up the wind data. And then within the louvers, there are pressure sensors, temperature. There's a light sensor on the top, which I'll show you in a moment. I found that really useful. The device itself is solar powered. And as long as it's within about 300 feet of a hub, which needs to be plugged in, it can transmit data to that indefinitely. So we've had one on the roof of the main building in which I work, Northside Hall at IU South Bend, since 22, running nonstop. I've touched it a few times just out of curiosity, but it hasn't needed any maintenance. So once they're going, they're really easy to deal with. Here are a few of them. There's one at Goshen High School. That's actually my favorite one because it was placed so well. It gets the most reliable wind data. There are no obstructions nearby. There's one right across the street from IUSB at Adams High School. A few of my colleagues have installed them at home. We will soon have one at Kennedy Academy. There are a couple of schools that have expressed interest. I hope to have one at Rum Village before long. So we want to keep extending this network because, again, the cost is low and it's really nice to have good coverage of the region. Okay, so I mentioned that there are lots of tools to look at information from weather stations that are readily available online. These are some examples of what one can do with data just from an app that's freely available from the company that makes the Tempest, or you can do it through a web interface. It's really very nice. The downside, though, is that it's limiting in the sense that you can't readily take different pieces of information and overlay them, which is something that is especially useful for identifying correlations between temperature, pressure, humidity. So for that, it's nicer if you can actually have the data to then go use whatever software you'd like to do more sophisticated visualizations. So to do that, I've been working with a student who is now a graduate student at IUSB. She's actually working at Notre Dame, so another nice connection between our two institutions. She's a background in physics, but is now finishing a master's degree, and she does programming and some applied mathematics. she's done all the hard part of this project, like literally all of it. She does the coding in Python, she does the web management, etc. And so that is Lei Li. And the key piece here is a web interface she has made. So she has scripts running that every day ping all the stations in our network, pull that data into a centralized database hosted on IU servers. And the reason for doing that is so that we could add stations from other manufacturers, or if, hopefully this won't occur, but if the company that makes these were to go out of business, we'd have the data readily available. And then there's a web interface for it, and this is really the key piece. So you can select one of the stations and then tell it the dates that you want to download data from within that range, and then have it readily available to use Excel or any graphing software you'd like to use. There are plenty of things that are freely available. I happen to like to use a platform called Igor Pro, but that doesn't matter so much. It's having access to the data. So here are the stations we have currently installed and running, one of which wasn't mentioned so far. Wade runs through Notre Dame, just south of Niles, right on the St. Joseph River. In fact, the station is literally on a tripod in the river. That's the Notre Dame River Observatory, so that's the one up by Niles. And we have a few more scattered around, and we'll keep adding to this over time. But so you can select one of those stations by name from the website we maintain, pick the dates, pull the data, and then do what you'd like with it to try to make sense of some recent phenomenon. So I have a few examples I'd like to show. The first one is from the eclipse that I'm hoping some of you got to experience, whether you were here locally for it to be partial or if you went somewhere for totality. I was out of town myself, but the partial eclipse provides some interesting information from these weather stations. What I'm showing here, this is all from the one at IU South Bend, shown in yellow there is just the amount of light that was being received by the station as the eclipse came in. So this was a partial eclipse. It got to about 97% toward totality, and you can clearly see a dip. Before that, a little earlier today, there was some noise. That's due to cloud cover coming and going. And now an example of what I find especially useful to do with this is to make some predictions. So you might be able to see that now on the right, there's a temperature axis. So what might you guess would happen with the temperature as it gets darker? It's going to drop. So there, you can see the temperature very clearly drop. Now I've set those scales to make the minima lined up, but you can see how strong that correlation is. But there's another effect that you might not immediately recognize as real and expected. If you look at the bottom part of the yellow and red, you can see the red lags the yellow a little bit. That's because there is a delay there. That's a common occurrence. That's why typically it's warmest late afternoon, even though the sun would have been at its highest point, depending on where you're in the time zone, at your local noon. I mentioned it's nice to have stations that are geographically separated from each other. This took a little bit of extra analysis and some fitting, but I wanted to try to resolve where the minimum was in the light curve at IUSB versus the Goshen High School station. So this is zooming in quite a bit and normalizing these, but you can see the minima you can actually resolve that as Earth is rotating, this is going 1,000 miles per hour, but you can resolve that difference in time where the minima was at one station compared to another. Let's see, now this is just more classic meteorology. Here I'm starting by just showing some correlations, and I'm starting with wind data. Now in case you're not familiar with how wind data is sometimes represented, in this case I'm showing wind barbs. They're like an arrow that's flowing with the wind. So imagine an arrow with feathers at the back and a point at the front. So in the upper left where you see those wind barbs pointing to the right, that's because the wind was westerly. You name a wind based on the direction from which it's coming. So that wind is blowing from the west toward the east. And then you can see near the middle of the plot, it starts to be coming more from the northwest, and then it shifts back to being from the west. You might also notice that the feathers change a little bit. When the wind is stronger, there are more feathers drawn, and the shapes can change a little bit too. But generally, more feathers means stronger wind. So could do another prediction. So notice that this was in February, so like we're definitely in the winter part of the year. What might you guess would happen to temperature when the wind would shift from westerly to a strong northerly wind. I think the temperature would go up, down. And you might guess the temperature would go down, so you can check things like that. Oh, I forgot, I put these on here in case you weren't familiar with wind barbs showing the wind directions. But you can see that shows up really quite clearly. So you go to northerly winds, and the temperature dropped precipitously. It got very cold, and then it shifted back to westerly winds, and the temperature came up. Now, another phenomenon you could think about, another correlation that's really common with weather data, as the air gets much colder, could you make a prediction what you might expect to happen with the atmospheric pressure? So I think colder air, would that make? Yeah, so we get colder air, the air is going to be denser. The pressure comes from the weight of the air above you. And sure enough, you can see that as the temperature goes down, the pressure rises. So I find this much more satisfying to be able to make a plot like this easily right as this occurred, so the very next day I could go into a class and say, okay, so you experienced this last night. Let's see what you might have felt and if we can resolve that with our weather stations. This one's a little more recent. This was late March. You may recall we got a pretty significant windstorm in late March. This one was especially fun for me because I was in Pennsylvania to give a talk. And I'd had dinner the night before, and then I was driving back to where I was staying for the night to give the talk the next day. And I was going to include some of this stuff in the talk. And as I'm coming back, I start getting some text messages, which I was surprised by. I don't get a lot of text messages. One was from Wade, and one was from my wife. And the one from Wade was to share this video. Oh, there we go. So if you can see on the left side of the image, that's the Notre Dame River Observatory tempest. Water level's up. It's clearly on the river. You can see the storm coming in. And then the next message was from, guess let that play again.
You definitely should have sound on this because it's horrific.
Yeah, I'm sorry for the lack of sound. Okay, so then my wife sent this picture of our trampoline. We've managed to rebuild, but that's the first time it's ever been moved before, so it had been blown over on top of our shed. And so I could pull the data right away. So in this case, the wind for the entire storm was very strong southerly wind. And you can notice by the feathers on those wind barbs that it clearly picked up in the afternoon. So we see the wind coming in. And then we can think about other weather elements. So in this case, what we see is that the wind it's southerly, so it's blowing from the south to the north. It starts to get stronger. What might you guess would happen to the temperature here? Guess the temperature might go up. So sure enough, we see the temperature rises pretty rapidly. So that's enough, you would perceive that. But then a little surprising thing, that the wind continues to be southerly, but that drop in temperature is really striking. As a very rapid drop. Look, we're sitting at, if you look at the temperature axis, we're coming up to, down to about 14 degrees C. So we're dropping about 8 degrees Celsius very rapidly. Any idea what might have caused such a rapid temperature drop? I heard someone say it. Rain. So we can then look at when precipitation occurred. And you see, sure enough, bam, there was a really sudden onset of heavy rain, and it accumulated pretty quickly. That upper panel is showing in the lighter blue. That's how strong the wind was hitting the sensors. And then it's got an algorithm to try to estimate how much rain is actually accumulating, which it cheats a little bit and works with the regional model as well. So the rain really picked up. And then you notice it's dropped the temperature, and then the temperature started coming up again because we still had southerly winds. The last piece I want to show here, I think you might have guessed this pretty well, but with that very rapid temperature drop was the moisture or the rain coming down from high up, cooled the air rapidly, pressure spiked up. So we see that pressure drop and then, pressure increase, and then the pressure dropped again as the temperature warmed. A little more recently, this was early this summer, where we get a lot of really nice thunderstorms in the region. So here's one where I'm starting by showing illumination data. So this is light at the top of the weather station. And you can see that the illumination is dropping really rapidly. Now it's evening, but I wanted to make a note that you realize that at this point, early June, sunset's not until after 9 o'clock. So this is a surprise that it's dropping so much. You might guess that that was indeed, this picture's not from the event, but that was due to clouds rolling in, and that the Tempest stations have another sensor that can detect lightning and make an estimate for how far away the lightning strikes are occurring. So I added to this plot, you can see on the green axis, you can see the lightning strikes getting closer, closer, closer. And then all of a sudden, very heavy rain, and the storm actually hit. Similar as we looked at already, again, a very rapid drop in temperature that happened right as that precipitation occurred. And then the storm passes and you see the lightning strikes go away. So we can just keep track of these parameters, and it gives a good understanding for these classic phenomena that occur with such storms. And then humidity spiked up, and this is really kind of what a lot of our summers are like. You know, that moisture can stick around for a while, and that's what makes it a little less pleasant that time of year. Okay, the last sort of case study I wanted to look at was another thing I'm finding really useful for having data like these so readily available. And that is comparing what's happening just from one year to the next. And are we able to discern things that might be related to weather versus climate? So what I'm looking at here, and I doubt you remember this might be too far back now, but around mid-May, it got really hot this year. And enough that I was hearing people saying, oh my God, global warming. You know, we're really getting a heat wave that's unusual. But the comparison I want to make, and I notice I'm switching colors here. So red is hot, blue is cold. And just comparing to last year. So you could see that 25 really was significantly warmer for those few days than was 24. But then the latter, coming in the latter part of the month, it actually got a lot colder, like very quickly. So it got hotter and colder. And now I'm going to take the colors away to not alias that, just to see the comparison. I've been running this since for enough years that I could go back to 22 and just throw those data on 1 year after the next. And what I want you to note from this is how much noise there is in the weather data. I mean, these are really quite variable. The range for which 1 year to the next, that would really fit within just weather variability. That's kind of hard to take all in. A better way to visualize that might be to take an average, even over just these 4 years. Now, if we were looking at this to really study the climate, we would want longer term averages, and we'd want to use many stations, covering as much of the planet as you possibly could. So I'm not trying to really answer, can we resolve the climate signal? I just want to show the weather variability here. And why, a key point, it is so hard for an individual to perceive climactic changes compared to weather data. That doesn't mean it can't be done, but you might want to talk to like an ecologist who can keep track of things like when you see migrations occurring, et cetera. Those things you can observe, but from just perceiving the weather, it becomes much harder. So I have the average here, and then a statistical way to show how much variability there is in the standard deviation. The standard deviation is really huge, just over these few years. And then we can compare to that, we can put 25. So 25 really was unseasonably warm, but I wouldn't say that puts us out of the realm of what we'd think would be reasonable. And then it actually did get unseasonably cold. But to really make sense of this from a climatic standpoint, that's why we want to have weather data from around the globe and as much of it as you can get, because the weather variability is so high. And the climatic signal, which is real, it's a much more gradual change. Okay, so I would like to ask Wade to come up now.
Right, so there's a secret. Wow, clap. There's a secret to make the applause fast for him. So it's like 1, 2, 3, clap. Ready? 1, 2, 3. No, just once. All right, thank you very much. Sounds very loud. So we're going to segue right to a couple of points that Henry just made, which is that getting real-time data is essential to really start the data processing and really getting scientific value out of it for the public need. So my preparation for this talk was starting at 6:30. At 5:15, I downloaded the City of South Bend's air quality data to give you a reference of what is going on with air quality. So my talk is going to talk about air quality and water quality locally and globally. So this is part of the network that South Bend deploys for air quality. And it's just air quality. These are single scalar values, which are just concentrations, particles, pollutants, carbon dioxide. What was shown with this is a transport physical phenomenon with the wind speed, the rain impact, the solar incidence and radiation, relative humidity, barometric pressure, the temperature of the air, and lightning strikes. So the combination is really key. So here is global map. You can see the colors. Red is bad, and the red coincides a lot with fire that take place through the US, Canada, and Mexico. How many people look at this data of the City of South Bend? Besides the City of South Bend? So we're going to get really local. This is the network of the City of South Bend. You can see green. It's pretty good. This is right now, an hour ago. So looking at it, and this is just a precursor before my talk actually starts, when you can see, here's about the past week, the daily trends. This is ozone. You can see ozone dropping. I'm not going to discuss why it's dropping right now unless you know or we go to the question period. But right now, ozone's dropping. You probably don't like ozone. You do on a climatic sense, but you probably don't want to breathe it a lot. Then you have carbon dioxide, right? So we're in the city. Here's 3 different stations. You can see I picked up Rum Village, which only has an air quality sensor. It does not have a meteorological station that was discussed. And then I picked up a block away at MLK and Jefferson. And then where else did I pick? Fire Station 7 is in a tough part of the neighborhood here. So you can see the variability, right? Things go up and go down. We can explain that again during question period if you're interested. But you can see there is variability. They do match up to each other. No one looks at this data. Anyone here not from South Bend and the surrounding area? You're not from South Bend and the surrounding area? Now. And thank you for participation. So, well, you all have relative interest in your air quality, right? For some climatic input, think locally, act globally, other way around. And then last is particles, right? So particles are a really good proxy for the quality of air. And this is PM, I think, 2.5. The sensors also get 10. Okay, so air quality, I think everyone is conscious when they smell smoke and things like that, but it does affect physiological parts of the body in some pretty bad ways, right? So it's all different parts of the physiological function of the human body, and it can seriously cause health problems. In big cities, the most expensive cost is when folks have to go to the emergency room because of some bad air quality. It's really expensive. All right, so my talk starts here. That was about air. I'm not really an air guy, but I do air. I'm really, as you saw from the introduction, thank you very much for your research on that. And it's Woods Hole Oceanographic Institution, not institute. That's where crazy people go. So you can see me underwater. I've been underwater many areas. How many people here regularly swim in the St. Joe River? Technical folks half raise their hand. Okay, so you can see now that package of me. It's those of you who watched the Graduate movie, this is my graduate moment where he's underwater. I hope some people get that. So but in the foreground is my sensor package underwater, right? So I put sensors like this integrated one that you've seen here, underwater, on the surface of water, and in the atmosphere to understand how our ecosystem is actually working, whether it's healthy, what's its performance. And then my specialty here on the right-hand side is the interface of water bodies, typically the global ocean. So this is something probably no one knows, but data that is available to you in the global ocean, we're concerned about carbon dioxide accumulation in the atmosphere, and that is pretty much uniformly distributed around the planet. But the ocean and its ecology and its physical properties have distributions of CO2 in the water. So here's the surface ocean concentration. And of those of you who are carbon dioxide buffs, the concentration of CO2 right now is about 426.25. And this is the evolution of CO2 that's in the water. So where the CO2 in the water is lower than the atmosphere, CO2 is getting sucked up from the atmosphere into the ocean. Where CO2 in the ocean is higher than the atmosphere, it's going out. And that gives us a budget. So this is work that I've done for 40 years. And when you accumulate all of that data, you can actually then understand how much the CO2 is going in and out of the ocean. So I can give you a ballpark. You can ask during question period how much we put into the atmosphere, how much of that goes into the plants, how much of that goes into the ocean, and then unfortunately how much stays in the atmosphere. These are places on the planet that I have observed these processes. And basically my favorite song this past spring is Johnny Cash's song, I've Been Everywhere. Okay, so these are type of instrument platforms. You saw this beautiful little sensor. You can see some of these. I'm just going to point out to one, right? They go everywhere. But at the top left is a NOAA ship called the Ronald H. Brown, in recognition of him. And on the tip of that mast is a bunch of sensors that look just like this. But with the addition, and hopefully this works with sound. Good job, guys. Hopefully it will stop. These are a bunch of sensors on a green roof, right? So green infrastructure, which the city of South Bend is working hard at adding. They're on college campuses. I just came from the Columbia University, and we had 10 green roofs there. There's green roofs on Notre Dame campus. So the point is to monitor with sensor data. So you see this mast that's very close to the ground. It's basically a bunch of these sensors with the addition of, in this space, so the mechanism to measure the wind is actually the speed of sound, because the space between this gap, there's actually little hydrophones which make a sound. So if I said hello at the same time you said hello to me, if we heard each other at the same time, there's no wind between us. But if I hear it before you, then the wind is going to go in that direction. So carbon dioxide has a similar mechanism for sensing, and that is the absorption of CO2, just like in the atmosphere. So in between this space, if light is absorbed more, then there's more carbon dioxide in that space. So I make that measurement about 20 times a second in order to figure out the transport of carbon dioxide, heat, water, momentum. So out of all the things, this slide is something that you should think about the most for scientific data and why we use it. Because there are a bunch of reasons that we need to figure out if we are sustainable. Because if we're not sustainable, it's not going to last. And each one of these processes that the planet provides is something that we want to figure out its performance, its metrics, basically report it and verify, instead of understanding something that's just made up and guessed. We'll come back to that again. I'll put this one up and you can ask specific about this during the question period. Okay, so first water, real quickly. Here's our watershed of the St. Joe River. This one is a repeat. Ooh, no sound. Maybe there's not. So birds are a really good indication of a healthy environment. I spent 10 years working in Haiti in the same processes of water in the mountainous region. No birds on that island. And you can see the sensor in the water behind that bird. You know, I'm so nervous, I don't even know what type of bird that is to say right now. Do you know? What is it? What kind? Great blue herring. What? Heron, see? We don't get many of these in the East Coast. Okay, so rivers, if you see the river in St. Joe or a tributary turning red, don't call 911. I've sent Barbara pictures of me putting dye in river systems. So this is Haiti, actually. So finishing up, and I'm really trying to create this background of the intensity of the sensors using publicly available data and add-ons of high intensity. So here is the Niles River Observatory. And after I coined that, it's not the Nile River Observatory. It's in Niles. And in there, I basically put what's called the kitchen sink in the river. So what the station is doing in that mast basically is the old school version of the weather station. And then what's being measured is the concentration of carbon dioxide and methane in the river. And then a specialty that's taking place right now, I'm measuring how much CO2 is going in or out of the river, right? No one knows that. No one knows that. They can guess it by models, but we're measuring it with the data. So I'm not going to focus on this one. I want to move on. But what I wanted to show, this was from a science talk, but in the left, I have internet cameras that make my own Wi-Fi hub, which is how the Tempest station is being measured real time. But there you can see the graininess, the reflection of light on the water surface, and that's a really good indication of the wind speed. So the top picture is no wind, to the bottom picture of high wind, to the picture that was shown during, I think, a tornado. And that all actually controls the transport of gases in and out of the water. So you need to know the physical, biological, and chemical processes that are controlling these transports. So here, during the winter time freeze, this is the increase in height of the actual river. And I think because of the length of my presentation, I had to take out, but during March maybe, and we basically were just going to sacrifice this precious instrument that's sitting in the river. The water level came up to here. So the increase in flow, which is indicated by this graph, going from about 4,000, I haven't seen in my 4 years here in South Bend, 10,000 seems to be the peak. That's cubic feet per second, the volume of water going down the river. It seems to flatten out there. And that's probably because when you're getting that high, you're starting to really get out to the floodplains, and you really kind of stop it there. So to finish up the water quality section, these are basically bacteria plates. It's a low cost. We compare that to high-end sort of EPA testing. But the blue dots are on those slides are E. coli, and you need to listen. And those are the hot spots. So we coupled this E. coli, biological, an indication of fecal matter bacteria, which is an indication and proxy for pathogens, with very high-end measurements of chemical speciation of the whole carbon cycle, what the river's actually doing. Maybe you can guess how much carbon dioxide is coming in and out of the river, how much methane is coming in and out of the river. These are indications of the water quality. And when there's questions, you can ask me, what's the health of the river? And as a joke, which I gave to a talk at Barbara's consortium, is that some community members like when the river floods. So things that we work on with data is we instrument to look at green infrastructure. So all of those 9 that I listed, all of those, we want to know what the performance is, whether you're putting in different pavements and other types of green infrastructure, trees, what that does to all of that ecosystem health. And then the homework with the New York Times. So about 15 years after my career started, when I went from Woods Hole Oceanographic Institution to Columbia University, New York City became this great new urban laboratory. And I started a network of carbon dioxide sensors back in 2007. So 2009, it got picked up in the New York Times. So I want to point out a couple of the articles in the New York Times. The first one is Sniffing Out the Truth. And essentially, because of weather networks, because of air quality networks, you can then say something happened, and then you can forensically figure out what happened. So there was basically a really, really strong smell in New York City. 8 million people said, what the hell's going on? And no one knew except for us who had a dearth of sensors to figure out which way the wind blows. Then we had another New York Times article the next year because there was going to be a law saying no one can put up sensors in the city. And that one, I ignored the law. And so we got another article. Okay, so wrapping up the air quality component and our talk, not yet, is looking at the really high resolution. So I showed the ozone going up and down. So here you can see the difference between ozone concentrations in the winter, ozone concentrations in the summer, and that gives us an indication in the health of our mixture of a rural-urban community we have here in South Bend. And then we can look at the diurnal variability. And what that tells you is when you should do your morning run or when you shouldn't, because there's a very fine line when there's too much CO2 and too much ozone in the air. So a shout out to the sensor network. The CEO is now my buddy, and they provide this package so you can really do snapshots of what the distribution of the air quality is. And what I want to say with that, so the background of air quality network on a temporal and spatial variability, a meteorological station of which way the wind is blowing and the dynamics of the environment, temperature, moisture in the air, sun levels, which are all factors that indicate it. But what my laboratory does is it takes those variables and uses different types of physics and chemistry to do mass balances. So we can figure out actually how much is being emitted because it depends so much on the weather, the climate, and the activity of the population. So I'm going to wrap up with, here's a book of Indiana rivers, and there was a frozen one of the St. Joe, which I grabbed for display. And then, this is a great moment that I wasn't even going to put into my talk at the embarrassment of my co-speaker. So my class deployed, I love the Midwest because it's so cold. And your river actually freezes. And it takes a lot to freeze. It's not 0 degrees. It actually has to be much, much colder because there's heat coming out of the earth underneath to keep it not frozen. So it was so cold, I had my class deploy a sensor below the ice. I got yelled at and reprimanded from my department chair for safety practices. And there's a good reason for that, because my laboratory forgot to bring sensors to collect water samples. So I had to go back to the laboratory. And it turns out that he fell into the ice.
Just one.
Sorry, just one leg?
Just one.
So I'm going to leave it at that and open it up for questions. And I didn't even remember that you fell into the river because of me. Thank you very much. Oh, I have to show Do it now?
Oh, no, you don't have to show that now.
No? Okay. Well, I'll put it up. Actually, well, let's just see if it's there. It is there.
I'm wondering, we've had so many forest fires lately, all around the world actually, and I'm wondering how significantly has that CO2 number gone up on account of those forest fires?
And the answer is a lot. So when we look, so I'm going to use that to help you ask the question that I asked you to ask me, which is, we are emitting CO2. The green energy that's used to these lights is not 100%. So we're burning CO2. So every time I breathe, not my CO2, every moment the atmosphere is going up in CO2. Now it's higher. So as it goes into the atmosphere, it gets mixed around with all of the weather. 1/3 of that goes into the growing of the trees. I'm going to, answering your question. 1/3 of it goes into the ocean. Unfortunately, 1/3 of it stays in the atmosphere. And it's going up and up and up. And it's now higher. So forest fires, and that statement that I just made, 1/3, 1/3, 1/3, it actually isn't perfectly 1/3, right? It varies on the water cycle. So when you have growing areas of the planet, when you have a good water cycle that year, it's going to take up more CO2. So the disturbance, they call it disturbances of whether it's dry soil emissions or forest fires, that those years it goes up a lot, especially when you have big volcanic action as well. The exact number, I can give you a range of percentages, but certainly noticeable. What other questions did I ask you? He has to ask me the water quality of the river. Yes?
I live outside the city of South Bend. I heard like in July, there was a smell in South Bend, accumulating downtown. Was there anything related to the one that you measured in the city? Like the same source, different?
I was in Massachusetts in July, so I didn't hear that to look at it. But now that you've said it, I can look, and we have all the data to figure out if there was any disturbances. Was it a week, a day?
I think the news media said like a week or so.
Okay, so it's persistent.
We didn't have much rain and a higher temperature, and they think they come out of the sewers with storm surge, maybe creating it.
So not the reason, but the reason your plumbing in your house has U-traps, right? So your toilet has a U-trap, your kitchen sink has a U-trap. That's because you want a water barrier in there. But if you leave your house for a year or 3 or 4 months, the water in that U-trap evaporates and you will smell the sewer. So there's possible connections physical to that. I'll wait on telling you what the river does. Questions?
Well, one thought on that is actually where we've been using, I work for the City of South Bend, Office of Sustainability, and we get complaints sometimes about the sewer smell, and our Public Works Department had us add on like the sewer sensor, sewer smell. What's this, the actual chemical that is like,
Sulfur.
sulfur dioxide. So we put on some sulfur dioxide sensors because it's been hard for the city to know when we're having problems or like what the pattern is, because we only get calls when it's really bad. And then actually we'll get more calls when it's been good for a while and then it gets bad again. Then you see a huge spike. So that data of the calls coming in is not related to the source, and we're very interested to understand where are the blocks. And so these air quality sensors can actually help us suss out where are there some potential places in our sewer system that aren't functioning properly, better than just waiting for our customers to respond by by the nose. We've got devices for that, so that's what we're
It's a really good sensor, the noise.
Yes, especially for like hydrogen sulfide. Like, we're really good at detecting. So you've got a tremendous deployment of human sensors to utilize.
Exactly. But they only alert at, sporadic times. Squeaky wheels.
Mm.
I have a question about the future of, so we have South Bend air quality, and we've been talking about some potential future developments around water quality. How do we better answer this question for residents of how's the water? Where is the water? How does water move in our community? And I was wondering if you guys could speak a little bit to our unique hydrological environment in South Bend, being part of 2 watersheds, and how that may or may not relate to air quality, storms, and climate, sort of readiness.
You just want to say something? You've been here for a long time. I'll say.
I tend to have a pretty optimistic view. A nice thing about waterways is if you stop polluting them, they recover pretty quickly. So if we are able to reduce the point sources and better moderate the CSOs as is happening, those improvements can be realized quickly. So the optimistic view I take is that if we committed, we can make it so the St. Joseph River would be swimmable most of the time and quite healthy. But I don't know if that really is answering your question.
I'll take some comment and stabs at it. So one thing, as Barbara and my interaction with her, so I'm 4 years now here. So I'm now involved with all the players, right? I have to meet with Lewis next week, who started the smart sewers. So the smart sewers, I'm not completely familiar with the background. All I can say is that, from the horse's mouth, is that we violate EPA's limits all the time. So South Bend gets sued by the EPA, or they used to get sued.
But we're not unique. This is very common.
Yeah, it
like
is.
South Bend is an outlier in terms of
Right.
being.
So to try and mitigate getting sued, South Bend has built a smart sewer system where knowing the dynamics of the sewer system can hold back water, and knowing in a smart way with valves and control. That is not actually operating yet. So it just started. And so the verdict's still out on whether or not that's going to happen. So speaking in terms of the very specific, like every sewer shed, every watershed is like a different child, has a different fingerprint, right? They're all different. They behave physically the same, but South Bend is unique because it's very flat here. So the river has a very low profile. It's not like a mountainous river where you have some gradients and you can really wipe it out. So there's a residence time that's specific to South Bend, a lot of agriculture around. So you have this sort of perfect storm of sewage from combined sewage overflows, at the same time this pulse of agricultural runoff. So it's very unique. Actually, the most recent National Science Foundation grant that I put in, I still haven't had the verdict. My Michigan State colleague put the word climate change in the title. So that wasn't smart, because it really isn't about climate change, but she's just building her career on climate change. But we're looking at the dynamics of agriculture and greenhouse gases and nutrient input to figure out what are the greenhouse gases concentrations. And the big violators of greenhouse gas accumulation is carbon dioxide, methane, and N2O. And they're all related to ecological and watershed processes in rivers. And all rivers behave differently depending on the profile, their size of the watershed. So I don't know if that answers your question, but basically I want to say we're on it, and we're having sensors, in to look at that coupling, and it is a strong coupling. the actual tie between air quality and water quality isn't huge. A little bit, like the methane signals. And by the way, yeah, so last week's, this is sort of a one-on-one conversation right now. Last week, Carl called, I'm getting the first TELUS methane sensor. And then just another hype is that we're putting some sensor packages on all the robots in Notre Dame dining community. So you have basically everyone, some people may be shy away from getting sensed and having weather and climate getting sensed, but you can imagine robots just doing 24/7 missions. Everyone respects them because they're delivering food and it picking up the whole heat island of the system. So we definitely want to put them in South Bend as well. Yes?
So where do you think putting more weather stations and air sensors would be most useful to improve the data for around here?
I take an opportunistic view, where are the easiest places to deploy that can be stable? I think the more you can have, the better. But I'm not aware of specific deserts where we're not having coverage that are creating an information gap other than more is better.
So my perspective is the accuracy of the sensors. So I think the density right now this is very pioneering to have a city the size of South Bend have so many air quality sensors, right? So since there is kind of a dearth of meteorological weather stations, so we need 5 more, like literally just not that much more. The city does have rain gauges that are distributed as well. It's not public, but it's there. So my approach is to use the sensors that we have and make sure they're calibrated and accurate. So even though we have many, they are still low-cost sensors. So like the carbon dioxide measurement is $199. That's on the South Bend, $199. The carbon dioxide sensors that I have, just one of those, is $145,000. And some sensors are $85. So there's a really big difference. But the variability slide that I showed you, right? The neighborhood variability of CO2 diurnally going up and down ozone, those are real because difference measurements, like the change, is pretty accurate. It's the absolute accuracy that can be suspect.
I was just curious, in your graph of the carbon dioxide in the ocean, just curious why the level is so high in the equatorial Pacific area.
He's not a plant. My usual comment when I show that slide, and it's weary to not have it into a specialist community. My favorite zone, I'll answer your question. My favorite zone is the North Atlantic, because if you look at the annual cycle, it's always red in the equatorial Pacific, except during El Nino, which isn't in that graph. But the North Atlantic is cool because you see in the springtime, it gets all purple and blue, and that's because it gets warm enough and all of the nutrients in the upwelling there suck up CO2 really big. The equatorial Pacific is an easy one. So the ocean movement, it's a big upwelling zone, so you're getting 1,000-year-old CO2 that's always coming up to the surface. And during El Nino, because of the capping in the warm layer, it actually becomes a sink. But that's every 7.6 years.
Overall, it's the same, the river fairly clean, I guess.
He was supposed to ask that question.
I don't swim, if I use the water.
It is clean. It just has a lot of poop in it.
The CO2 content.
Oh, yeah, okay, wait, yeah, so let's talk. So I'll be measuring CO2 tomorrow, and right now, I was gonna have those slides, but So the company that makes a little bit more expensive CO2 is giving me, so I get to be the poster boy in a lot of these things, has just given me their new product, which is, again, it almost looks identical to this, but it also measures CO2. So every half hour it's telling me how much CO2 is coming in or out of the river. So what's your question?
Yeah, I just wonder how high
It's really big. It's really big.
because it is a good fish population. You know, it's actually known as a very good.
Well, fish don't care about CO2, they care about oxygen.
Yeah.
Oxygen is A-OK.
Is oxygen fine?
Oh, oxygen is beautiful. In fact, oxygen goes supersaturated, which means that there's more oxygen in the water during the day because of the productivity in plants, and then at night it goes subatmospheric. So it becomes, all the respiration dominates. But, so the CO2 in the air, right, from the sides, it's like 430. It's really low right now, right? Air quality here is nice today, which is surprising with the temperature. But it's about 420. So the St. Joe concentration of CO2 in the water, and if you saw the global map, high was, it's all relative because the atmosphere is always going up, and it's now more than it was when we started this talk. The ocean is like 520 is high. St. Joe River is 3,000. It's really high. So, but because it's so smooth and not much wind, all that CO2 is heading towards Lake Michigan. It's really not, a lot of it is not coming out. It's really low still because of the capping effect of water. Yes?
I was really glad that you asked that question because it's one that we get all the time as the city of South Bend, and one that we're really excited to work with professors from Notre Dame and IUSB. It's been really great to work on our air quality project because there's this system of green, red, very easy ways for people to tell. Is the air quality good or bad? Should I wear a mask? How can I protect myself? There's a lot of messages around air quality. There aren't a lot of messages or information regarding that around our water. And actually, South Bend, our water quality is something that we should be really proud of because we're groundwater fed. We do have really high fish diversity. We've had a huge comeback of fish diversity that Doug Deegan has documented really closely and has really great resources. That conservation success story, or success stories that are around in pockets, don't often get told. And the value of water, there's been a huge change where water in South Bend historically was viewed as a waste product, something to pollute into. You could tell the quality of the water, what shoes were being created because of the color of the water. And now there's much more of an appreciation of water. This is why all our data centers are coming here. It is a valuable resource. So I really hope that our continued collaboration with our local institutions can, keep shining a light on our valuable water resources that we have here, and do a better job too as the city of South Bend. And we're looking forward to trying to figure out, is there a way to kind of color code for people, or say you can swim, you should paddle on the river. People are really afraid of the water a lot of the time. So we can do a better job, I think, of showing people that it's a great resource that we should be using and protecting, just like air quality too.
Wade, would you agree that E. coli is probably the best proxy for the health of the river for swimming? Is that the thing you'd want to know?
That's a pretty good one. I mean, the other background toxins,
Yeah.
Pathogens, that cancerous things aren't really there. Only certain parks in our neighborhood.
And I think, the EPA goal historically has been fishable, swimmable, drinkable waters, and there's surface water and drinking water, which are different. And we don't want people drinking the water. But people definitely fish in the St. Joe River, know that it's safe to fish, really value that natural asset that we have. And there's a lot of recreation that I see people taking advantage of and knowing that value. And I think the swimming is a fun one, kind of a question that people really are curious about. Can you swim? When can you swim? We don't really have much of a culture around that or knowledge, but I think sometimes it's okay and sometimes it's not. But we have no messaging around it or the way to know, really, currently.
So, okay, to clarify, jet skiing into being an Osceola. Okay. My question is, where do you guys test the water? Is it west of the dam? Have you gone past the dam? And
This dam?
Yeah, the Osceola dam.
Because there are lots of dams.
Yeah, so does depth have any, does that change?
Is there a correlation with the depth and
Yes, yes.
the amount of fecal matter?
Yeah,
There is, and it's a counterintuitive. The more water tends to have more fecal matter. But at the same time, when it goes low, that's when you get like a lot of methane. Carbon dioxide is, but these things, methane and carbon dioxide aren't health risks. So there is. So I can tell you, in my perspective, right? There's a dam here. There's a dam in Niles, and there's a dam in Mishawaka. And I measured in all 3 basins and tributaries. 2 places on the Judy Creek. 1 place way out, my student picked, like way out east. Any other interesting places? Yeah. The Mishawaka wastewater treatment plant, Holy Cross. And try to look at the variability as well, right? Where do you swim?
It was Osceola.
Okay, yeah.
There's a lot of jet skiing too, and it goes on.
Just keep your mouth closed.
Which I
All right, well, let's thank our
Okay. There's one more.
You want to wait, before you clap, let's do another practice. On 3, ready? 1, 2.
There's been a lot of news lately between the ocean currents slowing down.
Ocean slowing down.
Yeah.
In some places, yes.
Right.
What's happening?
What's happening and how will this
It'll be bad.
affect the...
Bad.
Yeah.
I wouldn't want to live in Europe. Europe is warm because the Gulf Stream brings nice warm water there. And 200 years ago, there was a little ice age there. Probably very unpleasant. Yeah, so it is, and that has to do a lot with fresh water, as we have more freshwater input, temperature. So all of those things decrease the vertical mixing in the ocean. So the ocean, so even though I'm a mechanical engineer, I had to become an oceanographer. And the ocean has storms just like we have. So there's like all of these tornadoes and hurricanes under the water that keep the engine and the heat transport. So a big part, is getting polar warmth, like between the poles. So it is slowing down. And yeah, that one, in terms of fearing changes in our climate, concerns me the most, because big changes will happen, and it's plausible. But it's a hard one to predict. Yeah, so I'm from Cape Cod, which is where the Woods Hole Oceanographic Institution, we should go, is. But I grew up down the street, 5 houses away from Bob Ballard, who discovered the Titanic. So if you sense any sensationalism, I learned from the best. He's full of himself.
So if you
have any additional questions and you want to talk with the speakers one-on-one, you're welcome to. So this series, we have a talk once a month, the first Tuesday of each month, so the next one will be in October. In November, we feature the Nobel Prizes. They're not announced till early October, so once they're announced, we will pull together people who have expertise in that area, and we'll have a Nobel Prize panel in early November. And then in December, the person who started this series, Jonathan Krass, he's now at Ohio State University, and he develops instrumentation to study exoplanets, and he'll be coming in December to give a talk. So those are things that are coming up.
You want me to share that slide? I'll show you.
Oh, okay, sure.
Keep going.
So you can go to Our Universe Revealed, and then type in Notre Dame and it'll pull up the website. You can see events that are coming up. You can also look at events that have happened in the past. So if you missed a talk that you want to hear, you can hear it because they're being recorded. So anyway, thank you so much for
Your slide's
coming.
up.
Perfect, there it is, all it is.